You're listening to the Lean Six Sigma for Good podcast. We help you learn how Lean and Six Sigma concepts can be applied to nonprofits, NGOs, and not-for-profit organizations. Visit us at leansixsigmaforgood.com. Welcome, everyone. Today I've got Travis Keener. He's going to be talking to us about spills, prevention controls, and countermeasures. So welcome, Travis. Can you give us a little bit of background on your experience and how you got into this field?
I started out at Eastman Chemical, which was part of Kodak, straight out of college. I had a background in chemical engineering. The polyethylene division got bought out by Westlake Chemical, so 400 of us all of a sudden got new jobs. I could have stayed there and retired there, but we took that opportunity to take our two kids and move back to where we were from in Oklahoma. So moved from Texas back to Oklahoma. And so I started working for a contractor, and I had never appreciated how hard a contractor has to work to even be qualified to work for a big company. And then eventually I had this very interesting opportunity get dropped in my lap. I inherited a filing cabinet from a World War II pilot, and I never got to meet him, but it came through another engineer that I knew, and it had 700 spill plans in it, almost entirely from Osage County, Oklahoma, which is just northwest of Tulsa. And what's so unique, there's no other county like that in all of America where the Native American tribe has a minerals council and they own all the minerals under 1.5 million acres. So when you come into that county, you want to drill a well, you don't have to go talk to multiple landowners. You talk to one entity, and that's the Minerals Council. I just jumped into it. I was looking for a chance to start my own business. That was about 12 years ago. And the first part didn't go great. I was like 2 years worth of financial free fall, waiting on
Yep.
people to find out who you are. And that quickly led to me meeting other people. And the next thing I knew, I'm like in Los Angeles and Chicago, and I'm down in New Orleans. And now I'm licensed in 42 states as an engineer, primarily to stamp these spill plans. And so it just grew into a job where everybody I work for has an engineer already, typically, but they don't have one license in every state that they might have an odd job in. So I pick up the scraps from multiple companies and it turns into a full-time job. So that's the background of how I got into this business. The way I look at it as an engineer, the liability for me is not out of these 70 to 100 pages in this plan that describe all the parts and pieces of a terminal where gas is being loaded, or a jet fuel facility near an airport, or even up to a refinery. The thing that's most concerning to me is, where's my liability at? It's if a leak gets out of the secondary containment, if a tank leaks and then it escapes the berm, have I done the calculation right? Have I measured the data correctly in the field, and have I calculated it correctly? And did I miss anything? So I thought maybe today it might be interesting to describe to you what that process looks like when you go out and measure a containment. And
I was wondering if you maybe talk about what are those different types of scenarios where a spill plan is required. So you mentioned like some kind
okay,
of gas terminal, maybe it's
yeah,
underground gas storage. What are just some examples people might be able to relate to
okay.
that?
If you store something in a liquid form that can cause a sheen on water, you're probably in this EPA rule called the SPCC rule. Now you have to have at least like 1,320 gallons at your site, or else you'd be below the threshold. But most industrial people, they're going to easily get over 1,320 gallons. It's under the Oil Pollution Act, but it's called the SPCC plan. And it actually started in 1973. So it's been around a long time through many administrations. What I'm usually finding is it's the crude oil sites where you're producing oil in the field. It's diesel, gasoline, jet fuel at terminals that are distributing trucks out to all the gas stations where we go fill up our cars. And then, of course, in refineries and in big terminals. Now, there are some places where you have big tanks and they're just a tank connected to a pipeline. There is no truck or no train that takes any fluid out of that tank. That tank is not part of the EPA, that's under DOT. And DOT has a slightly different rule, but you still have to measure the containment of the secondary berm that's around that tank. So Anything that causes sheen on water, that leaves out things like propane, ethane, methane, the natural gases, the things that float in air and go away, that's not going to fall under SPCC. But it's also not going to be water soluble chemicals. Anything that mixes with water, if it's a straight alcohol, if it's an acid, there's some things that you definitely don't want escaping from your tank, but it just doesn't fall underneath this particular rule.
And then a spill plan basically is what happens or how is there mitigation in place if something ruptures or gets spilled and it goes into the ground or into the nearby waterways.
This spill plan basically helps people plan for prevention of a spill. So that gets into how do we inspect our tanks and maintain the integrity of our tanks and pipes so that the spill never happens in the first place. And then what are we going to do if it spills? Like, how much do we have on site? Who is our cleanup contractor? What kind of spills can we clean up within our own capability of the people that are here? What spills would need outside help? Where's the nearest waterway? Which direction is it going to flow off the site? How do I handle my trucks and my trains that are getting loaded? How do I even catch drips and seeps that might come out of the connections? It gets into a lot of the granular details, and it has phone numbers and all kinds of rules, sometimes state specific rules, but mostly it's all just a federal rule underneath the EPA that says you're going to call this agency if you spill this much, you're going to call the next agency if you spill more than that. It's a lot of paperwork, but I feel like the crux of the whole thing is, did someone look closely to make sure that last ditch effort of that secondary containment wall, whether it's concrete or earthen berm, almost like a pond dam, is that capable of holding the spill? The EPA was pretty insightful when they decided that you need to include some precipitation in that. So when I do the calculation as the engineer that signs off on it, I have to include sufficient freeboard for precipitation. And freeboard is the amount, if I had a pond right now and it had this much of space between the top of the water before it overflowed the dam, that would be called the freeboard. And so you have to have some allowance for precipitation. And that's a really big misunderstood part of this whole thing. And it can definitely be the tail that wags the dog because the EPA, even though it's not in the law, they suggest you use the 25-year, 24-hour rain event. And that can be a lot of water, especially if you're in New Orleans or Houston. If you're in Las Vegas or Phoenix, maybe it's not that big of a deal. But a lot of people have used just 110% of their largest tank. Unfortunately, that means you would build the berm the exact same size in Las Vegas as you would in New Orleans. And in Vegas, there's 2 inches of rain. New Orleans, there's 14. So it's much better to use the climatic data that's right there. And it's real simple to find. If anybody's interested, just Google NOAA rainfall data and you can put a crosshair right on top of your house, right on top of your facility, and this data set will come up down below that and show you exactly the 1 year, the 10-year, the 5-year, the 25, the 50-year. You can look at all kinds of scenarios of data. Used to, you have to pull out a contour map by, I think it's called Technical Paper 40, that was made in the 1960s. And you had to, figure it out yourself. But the rain's a real key important point. And I want to bring up just one quick thing. In America's largest tank farm is in Cushing, Oklahoma, west of Tulsa. And that's where all the gigantic crude tanks are. And 30% of the issues that they have there are related to lightning strikes that would light off some vapor coming out of the top of those tanks because they vent as needed. That kind of shows you rain is most likely going to be involved, or it's at least a 33% chance of being involved when you have a tank incident. So really thinking through the rain, I think the EPA was smart to say, don't just design the berm for the tank, design it for a rain event as well.
Yeah, I've used the NOAA site. I was trying to see if the house I was living in, when would it be affected if sea level rise went up a certain number of feet and like how many feet before it would start to get into my neighborhood. And so that was
Yeah,
pretty interesting to look at little models of how that
yeah.
works.
Another thing, if people don't realize, if you download Google Earth Pro and you want to look at elevation profiles, there's a ruler at the very top of the screen in Google Earth Pro. And if you click on that and you choose, it's either line or path, but you can click the little dialog box there that says, show me the profile, the elevation profile. And then you can drag a line like from, let's say if you live near the coast, drag a line from the seawater edge up to your house. And then as you move your cursor up and down that line, there is this side view map that's showing what the contour of the ground's doing between you and another place. I'm going to say it's plus or minus 5 feet. It's
Wow.
not like super tight survey data, but it is interesting and it does do a pretty good job of showing you what's going on. Yeah.
Um,
And that's just free. So it's kind of cool to have that. I like to use that sometimes before I go do a survey job to kind of get a little bit of a feel for what I'm getting into.
Another question about spill plan. Does that include some kind of ongoing monitoring to be able to tell if there's a leak that's unknown or something corrodes in the tank and it's spilling out, or some way of knowing if there's something actively happening, or do they rely on some kind of event that someone knows has occurred?
Yeah, I'll kind of answer about three different things there. So to answer your direct question, there are going to be two ways that I can think of that are going to be some direct monitoring. It's either going to be state level requirements where people have monitoring wells that they have to come and look at, or when I sign off on a spill plan or any engineer signs off on one, you sign off on five cardinal things. I know this rule, 40 CFR 112. I'm familiar with this site. I or my agent visited the site and the inspection procedures have been put in place. And basically, this plan is sufficient. So, inspection procedures, whether you're using API, American Petroleum Institute 653, which is for really big tanks, or whether you're using Steel Institute, which is called STI, you're as part of that inspection, there is some ongoing looking at the tanks every so many years, go inside the tanks and look at the floor, but also monthly rounds where you have to walk around the tank and look. One of the things you might could imagine it concerns the regulators and all of us is that what if a tank is leaking straight through the bottom floor going into the ground and we have no idea? Especially like Steel Tank Institute, if you have a concrete foundation underneath the tank, they give you some extra credit there and relieve some of the inspection burden because that's considered a release prevention barrier. And the leak would go to the concrete and then run to the outside, and you would be able to see it and you would know my floor is leaking. In terms of data and measuring and kind of the Six Sigma define, measure, analyze, improve, control, I just thought I might step you through what happens when I go to a site and I'm walking up and guys at small companies and big companies will be like, "What do you think?" I'm like, the one thing I know is that nobody can tell until you run the data. You just can't eyeball it. And there have been a few times I remember we've done all the elevations all the way around the berm. And like lately, we've been flying 100 acres in 45 minutes with a LiDAR drone. And so we're getting 400 data points per square meter. It's just massive amounts of data that we go back and model. And I hire subcontractors to do that. I work with some people that are really adept at that because it takes expensive equipment and expensive software to do it. But you get to the site and you're looking and you're wondering, where is this going to leak out at? So my number one concern when I get there is I'm going to find the leak out point, whether it's hiding underneath a stairway or a pipe rack, whether it's around the corner of a building that's built into the berm. I'm going to find that low spot because that's the number that's going to drive everything on containment. A lot of these tank farms are pretty uniform. They linearly flow toward the drain valve that lets you get the rain out. I'm looking to find out where's the breakover point at the top of the berm so that I know how much rain is coming into it and versus how much rain just sheds off the outside. And then I'm there to measure accurate floor elevations and get an accurate area. Now, one thing I'll brag on Google Earth is if you draw a polygon in Google Earth at the top and then the inner toe of the berms, you'll almost get exactly the same number from Google Earth as if when you measure it by hand or measure it with GPS or some kind of survey grade tool. It's phenomenal. It's the vertical accuracy that's still difficult. So I'm there to get really good vertical accuracy on my floor depths. And everything I do is in cubic feet because I'm going to convert it to gallons or barrels. A little bit in the spirit of Six Sigma. I don't want any tape measures on my job sites that have feet and inches because I don't want to deal with any inches. I want them all to be in tenths of a foot because everything I'm doing is getting converted to feet. So I buy special tape measures and all that good stuff because you're just causing yourself more work to have to convert later. And so we measure the containment. The rule says that the largest tank is the only one that you have to base your numbers on. So you don't have to go off of all the tanks are leaking at the same time. It's just the largest tank. So imagine a big tank is leaking and it gets down to 4 feet, and that's where the leak point is, about 4 feet up on the tank. So that tank does not displace its own fluid, right? It's got liquid inside the tank that's still in there, and then it's got what leaked out. So when I start doing all the displacement, I'm looking for everything that's in the way. And it's just basically what's the average floor versus where's this leak out point that I found? What's that average depth? Because again, the floor is shaped like this, and then the berm leak out point's up here. So what's this average liquid depth that goes deeper at the drain to shallower at the other end of the tank farm? And that needs to be able to hold the largest tank, and it needs to be able to hold the rain event. And I like to go off the 25-year, 24-hour because the EPA has suggested that for the last 20 years. And even though it's not in the law, you're at least not going to be accused of gross negligence if you go by what they've suggested for 20 years. But they're really smart on why they didn't put it in the law, because what if they tell you, hey, you need to plan for the 25-year rain event, and you do, and you have enough for that, and then you get a 35 or a 55-year rain event and it leaks out. And then you come back to them and you're like, hey, you can't find me because I did it like you told me to. They're not going to be pinned down to that. So it's always the engineer's fault. He's the one that should have known how to predict the weather. I'd say a lot of times when I say that 20% of the tanks are not adequately protected, I would say most of the time we have enough berm capacity for that tank. We just can't handle the rain that goes with it. And that's the problem with not being able to handle the rain, is once that liquid gets out and rain's going everywhere and you have a sheen on that water, it's going to go wherever it wants to go. And I would say a lot of times when it's time to tell someone, hey, your berm's not quite big enough, it's usually a simple fix. It's, hey, on this one corner down here, add some dirt to the top or raise the concrete wall a little bit. Sometimes it's really hard though, because there are pipes and conduit and all kinds of stuff sitting right on top of the concrete wall, and you don't have enough real estate to go out, and you need to bring that wall up. And a lot of times people are like, hey, what if I dig a big hole in the ground inside of here? And it just, that almost never gains you much volume, because imagine if a lot of these are as big as a football field, just going up an inch is going to gain way more volume than trying to dig a hole over in one corner. And then the problem with going out further is that you catch more rain. For every square foot that you go out, if you're in New Orleans, you're catching another 14 inches of rain in every square foot that you go out. So it's almost always faster, better, cheaper to just raise the walls right where you are.
Let me pause for a moment to tell you about our sponsor. Creative Safety Supply is a great resource for free guides, infographics, and continuous improvement tools. I recommend starting with their 5S guide. It includes breakdowns of the 5 pillars, ways to begin implementing 5S, and even organization tips and color charts. From red tags to floor markings, it's all there. Download it for free at creativesafetysupply.com/5S. I was curious what kind of mitigation ends up happening on some of the assessments you do and plans you review.
A lot of times you can share with your neighbor. So if you have multiple different containment areas, and a lot of times that's for fire code. Like a lot of times you want at least an 18-inch tall berm between all the tanks, even if they all sit down inside of a big bermed area. In between them, you want some smaller berms in case one of them catches on fire and that liquid's on fire and begins to ooze out and is going sideways. You don't catch the whole tank farm on fire. But a lot of times these tank farms, they are sitting next to other tank farms, usually the same owner. And so a lot of times I will design a spillway cut in the wall and we'll share with our neighbor. And that's how we gain the capacity needed. The only problem with that is anytime you cut a spillway, and I'm so focused on tank 1 leaking over into tank 2 area, but now tank 2 can leak back into tank 1. And there's been times that I've had double spillway cuts in the tank 2 area. So now I have to think about tank 3 over there. Is it going to come this way, or is this going to go that way? And unless the berms are not all pretty close, you can overwhelm a downstream area really quick, because you have a big tank up high on a hill, and when you cut that spillway, it now can relieve and go down. And that may be a little bitty berm down there. And if it's setting very far below this one, it just won't help hardly at all.
And when you're talking about dirt, does that change over time as it changes size dramatically, or once they built up a mound, or do they have to go back and check some of their calculations or see if anything shifted or adjusted?
That's a really good question. I find that the floor elevations don't change very much over time. You might go 10 or 15 or 20 years and not see the floor change much, but there's three main ways that the top of that berm is going to change. It can just be compacted, like you're talking about. And where I've seen it happen is these guys usually drive trucks over into the berm to access the tanks. There's also walkways, and then there are pipes that come underground to service these tanks. And when that ditch was dug years ago, the ditch will compact. And where that pipe is like flowing like this, perpendicular to this berm, I've seen like these 20 or 30-foot low spots that form 20 or 30 foot long across the top of the berm. And it goes down like 6 inches, let's say, and it turns into thousands and thousands of gallons of loss of containment. So I like to say, if you're familiar with tanks and steel tanks and pressure vessels, we build them with corrosion allowance. We build the steel just a little extra thick and say, hey, I know it's going to corrode a thousandth of an inch per year, let's say. Unfortunately, berms erode a lot worse than I've ever seen tanks corrode typically, and we don't build erosion allowance on these earthen berms. Like I've had numbers of times when I first started, I would tell the contractor, let's say 4.72 feet tall is how much this new berm needs to be. And I get out there to measure it, and I'm like at 4.715, having to round up to 4.72. And I'm like, oh my goodness. And one time it was 2,000 linear feet of concrete that got put on top of the wall. And I'm like right next to Qualcomm Stadium in San Diego. And I'm thinking, I'm going to have to fail this brand new project because he cut it so close. I'm going to be like, hey, I'm not going to tell you what the real number is. I'm going to always tack on a couple of tenths of a foot higher, and just give us all a little bit of ability to have some error in our measurement here. But yes, the berms erode, and you'll see a lot of cinder block walls, and those things are notorious for cracking. Like I had a project in Phoenix where I walked the outside of this one berm, probably 500 by 500 foot area, and I found every expansion joint that had caulking in it had been punished by that Phoenix sun. I could see daylight past the sealant. And then I found in the mortar cracks, I found probably 200 cracks in the mortar. So it's one of those things, if it's cheaper due to real estate issues to build a vertical wall, you then have to maintain that wall with sealant and other things to prevent it from cracking. I guess you would say there's maintenance involved with either kind of secondary containment.
Yeah, I think the idea of going out and walking the site, I think, is pretty powerful. We do that in our improvement work as we go and look at the process and look at the area and survey it and assess it. And so imagine you're maybe forcing people to get out there and look at that themselves if they're going with you, or maybe you're doing it yourself and you say, hey, I noticed these things. Have you ever been out here in a long time or even checked these things out recently? Maybe they're
Right.
blatant like that, or maybe you're looking for things they wouldn't notice normally.
Exactly. Yeah. Another spot that I've found a lot of times is sometimes we have these culvert pipes that go underneath driveways, and sometimes they're not sealed good. And then when people put in new walkways or they put in new pipe runs sometimes and they have to dig into the berm, they just don't put the berm back. It's just like it was in the way, so we got out of the way, we built the steps, or we put the new metal walkway over here, and then we never put the dirt back up underneath to the bottom of the walkway. And you're walking along, you're like, oh my goodness, this is like a foot and a half lower than the rest of the berm. And it's just, yeah, boots on the ground, a second set of eyes. 50% of the time with a LiDAR drone, we had data one time from an airplane in Los Angeles. 50% of the time it found the low spot, even though it was obscured visually, like under a pipe rack. But Other times it just can't see through some of the walkways that people put up. Usually it's got metal grating you can see through, but you need boots on the ground pretty much. When I'm taking on the liability of signing off on those plans as the engineer, I feel really good about independently finding that low spot instead of just depending on the drone to find it for me. For probably 10 years, personally walked the berms almost every time where I was on the job with the guy who was walking it with me. But here lately, because of the drone technology, people tend to want you to use the drone on big multi-acre sites. So like we did a refinery in Texas that had 40 containment areas across many acres. And I'm relying upon drone data that actually somebody else collected, and they're good at collecting, and their quality control printout for their elevation data was good. But now we have to really have some good point cloud data experience to be able to correctly interpret what we're seeing in that data. And as you might can imagine, you're looking at point cloud data and you click on a point, and you think you're clicking next to a tank that's in the foreground. You might be clicking on a tank that's 500 feet away, three tanks back, because you're looking at all of that point cloud data right there in front of you. And you just have to really be careful when you start picking and choosing data points to figure out where the berm's at. And then on other cases, like the drone is so good with the LiDAR, it's seeing down through the grass and it's getting a bare earth contour when you start stripping away those layers in the data set. It's possible the drone could find a low spot that I wouldn't have found if I would have walked the berm myself.
But can you explain the LiDAR? You said it's able to look down into the like ground level through the
Yeah,
grass.
basically, you have a spinning laser on the bottom of a drone, and it's collecting, like I said, 400 data points per square meter. And so as you fly the site, let's say you're doing north-south passes. If you want to double it up, you can also do east-west passes. Let's say there's a rock sitting out there. You may end up hitting that rock 12 different times from different flights that you went over it. And once the guy or gal takes the data and puts it into their software package, which like there's so much data, it'll crash Civil 3D AutoCAD. You have to run it through other things until you can put it into something like Civil 3D. And so you can say, give me the bare earth contour, and it's pretty much stripping away all this noise in the grass and beginning to isolate the data that seems to be corrected in an averaged out data continuum there to find that bare earth contour. Whereas if you're using photogrammetry, it's basically overlapping photographs give you depth perception. You can also do it with that, but you're not getting quite the same penetration that you do with the laser. So the laser is shooting out, hitting the ground, and bouncing back and getting reflected back to the drone. And that's how you're measuring it. And the GPS on the drone is tracking it. As the wind blows the drone up and down, it's got to constantly figure out where it was in space to keep accurate readings coming from that laser. In case any of your listeners are curious, I would say 5 to 10 years ago, that drone was probably $250,000 and the laser was 60,000. And now you might be able to get the whole thing for 60,000 if you're buying a Chinese drone. If the components or enough of the components are made in America, you're probably back up to $250,000 drone to be able to have that kind of a drone. And so I listen to these guys talk about the softwares they use to process the data, and it's massive. So for me, I don't do enough jobs to justify that level of expense, but these guys are land surveyors and they might fly 20 miles of an interstate for some company and they're processing lots of data. I just like the fact that I'm working with people that have been using point cloud data for 15 years. And as I'm stepping into this new technology and I'm putting my engineer seal on it, basically it's me looking over his shoulder as he gathers the data and processes it the way that I want it. But I'm really having to depend upon those guys to do it well. And every now and then, if it's a simple job, I still like just doing it with the old-fashioned tape measure and a laser level. I can do it almost as fast because I can start right off and I'm not waiting for all this setup time. Like anything, it depends on what you're doing.
Yeah, I think that's very appropriate. I think there's a lot of processes that we try to throw some technology and it increases setup time, but then, yeah, you save time on the processing and doing the work, but you can do it just as quickly and easily and more
Yeah.
effectively, and it's maybe too many extra things you don't really need. It doesn't really save time. So at the end of the day, it's like, where did my time savings go? Oh, I just shifted it to something else. And so what was the value and the extra costs that we're incurring? And what am I getting extra? And what is the customer getting for value in that? It seems cool, it looks
Right.
nice, but am I actually saving time or giving something
Yeah.
of more value? And if not,
Yeah.
then why are we doing that?
And when I do it the old-fashioned way with the laser level, I can answer questions right then. If the client's standing there with me and they're like, "Hey, I was wondering, does that drain pipe actually flow from here to there?" I wrote the number down myself. Whereas if it's something that we got to go back and process, that means weeks are going to go by and we got to go back to the office. We can't answer any questions in the
I
field.
see.
And so I would have to go back home, process data, and I like being able to answer questions in the field. In case your viewers would be interested in, I go to about 20% of the corn ethanol sites in the United States. So when you put ethanol in your gasoline, that's usually coming from corn or sorghum. And they have a situation where we're not sure it's the best situation, but they designed all these in the last 20 years to where when you're filling up a truck of ethanol, if that were to leak, it goes down into the concrete through a pipe and goes back to the main tank farm. And the reason why that may not be the best idea is because one time this alcohol caught on fire and now burning alcohol is flowing down a pipe headed to your main tank farm.
Wow.
Most time the rail is not set up that way. But like just last week, a guy was asking me, "Hey, the state wants to know if this big tank in the tank farm leaks, is it going to back up that line and come bubbling out at the truck rack?" And I was able to just right there answer that question in the field because I'm just using rudimentary measurement tools. They're accurate. After all these years of GPS, they still tell me that if you take an egg and stand it on its end, the XY variance that we have is about the width of an egg, and the vertical variance that we have is about the height of an egg standing on its end. Now, I have had GPS be super accurate for me. I can stand next to a concrete curb at a parking lot, stick my pole on top, connected to 17 satellites, stick it down on the parking lot, pull out my tape measure, and I'll be off by less than a quarter of an inch on the height of that curb. But most people won't guarantee that. And most people will say it's not always that good. Whereas if I'm out there using my laser level, I'm not going to be off more than an eighth of an inch, I don't think, usually on my measurements.
Yeah, we see that too. It's the desire to go to automation. You look at it and it doesn't really make sense. It
Yeah.
doesn't pencil out when you try to do the numbers of what the cost would be and the time savings and the effort and the
Yeah.
accuracy. And yeah, sometimes the simple old school process works just as well. And yeah,
Yeah.
there's different ways of doing it, but right now there's not any better ways. And
Right.
like you said, the quick response to a customer, that's has to be factored in, and knowing that I
Yeah.
can answer those things and give more value and more timely answers than just
Yeah.
I'll get back to you in a couple of weeks once the data gets processed. Right.
The only problem is I think it's also based on some magnetism. Maybe it's getting a compass reading or something. And when I get around big metal tanks, I feel like it's throwing it off a little bit. But there are some new technologies that are coming, and I think Leica, maybe I heard, has one that's not thrown off by the magnetism. And so I'm looking forward to using some of those things because now I'm not trying to connect to satellites. I'm just using motion that's relative to a starting point. So if my drain for the water is the lowest point and that's zero, and then I start every 6 seconds putting that tool on the ground as fast as I can walk, it's really cool. It makes colored 3D volumetric drawings and everything that you can send from your cell phone to CAD or to a PDF and email it to someone. So there's some cool new things that are coming. It's just like anything, you have to try to step into it. But we just joke, hey, we'll do it by horseback for now, if that's the best way. Spill prevention, control, and countermeasure is something that is definitely needed anytime someone thinks about protecting water. It's not like some of the environmental things that some people agree, some people don't. I think pretty much for spill prevention, everybody agrees. It doesn't matter what background you come from. And so it's turned into a nice niche for me. Starting out as a chemical engineer and now doing, so to speak, civil engineering most of the time. I would say very light civil engineering, getting into the compaction of the dirt and stuff like that. It's very unusual for a chemical engineer to be licensed in so many states because usually you work inside of an industry that doesn't require a PE license. So it's been a fun job for me, and I don't see it going away. I see states possibly getting more independence and coming up with even more rules that might be a little bit different than the EPA rule that's been around since 73. It's something that is important. And if any of your listeners know anybody that would need help on that, I started using the term, some lady in California coined the phrase spill plan man. So go to spillplanman.com and contact me, and I'd be happy to help on anything related to this.
And you're on LinkedIn as well?
Yep,
Okay.
LinkedIn. Yep. I try to post videos every now and then. I've posted some videos about the drone. I've posted some videos about how to improve the field measurements of these tank berm capacities and stuff like that. And I'll continue to try to put stuff out there.
Okay. We'll link up your website and your LinkedIn profile and any other contact info you want to share. I really
Okay.
appreciate having you on. This is really
Yeah.
fascinating and learned a
Thank you.
lot about how to prepare for spills and what to do.
Yeah.
So
Thank you.
appreciate your time.
Okay. You too.
If you like this topic, please check out the Lean Six Sigma for Good book series with the subtitle Lessons from the Gemba. We now have both Volume 1 and Volume 2 in paperback, ebook, and audiobook. Each volume has 8 chapters written by different Lean Six Sigma practitioners who have applied their skills to nonprofits, NGOs, not-for-profit organizations, and government agencies. Proceeds from the book sales are split evenly and go to the nonprofit selected by each author. Go to lean6sigmaforgood.com or search Amazon for Lean Six Sigma for Good. These books make a great gift for your process improvement team or someone you know who works at a not-for-profit organization.